Hi, welcome to section 11.7 notes on areas of volumes and similar solids. So in this particular case, if you look in this box here, it says if the scale factor of two similar solids is A to B, then the ratio of their corresponding areas is A squared to B squared. So that we have already gone over in a previous chapter, in chapter 10. But now we're adding something new here that says the ratio of their volumes is A cubed to B cubed. So if that is the ratio they're giving us, then we can set up proportions with that information. Again, we just have to stay consistent as we are doing that. So if we look at the first couple examples here, they're asking us, are the following prisms similar to each other? Okay, so in this particular case, if I go ahead and look at the smallest length of the small cube and the smallest length of the cube on the right, and I write that as a ratio, I've got 2 over 4. So in this case, we're going A over B because we're just going side length over side length. Those side lengths are not squared. They would just be like meters and meters or inches and inches. And that 2 over 4 can reduce down to 1/2. Okay. Now we can find another set of side lengths that correspond with each other, the 3 and the 6. And again, we can set those equal to each other. That's a new A and B value, side lengths, 3 over 6, and they reduce down to 1/2 as well. And if we go ahead and do the third side lengths, this 3 and this 6, we already have that 3 and 6 reduced down to 1/2. So if we get 1/2 for all of them, then we say that the ratios of the corresponding sides have the same scale factor, which is 1/2. So yes, these prisms are similar to each other. All right, so if we do the same type thing over here on number 2, then we can see that the height of both of these prisms is 2 and 3. So we can write that as ratio. We can look at the bases here, and we can see the length of the base is 3 and 6, the longer side of the base. So we've got 3 over 6, and it reduces down to 1/2. And then, because this 2/3 and 1/2 are not the same, that's the problem here. If I want to go and check the third set of sides, the width of the base, I can say 2 over 3. And so again, I have two ratios that are 2/3 and one of them that's 1/2. But for them to be similar, they would all have to have the same scale factor, and they don't. So are the polygon or prism cylinder similar? No, in this case. All right, next up, it's telling us that the shapes are similar, and it wants us to say what the exact scale factor of the smaller to the larger shape is. So in this particular case, they are giving us the volumes. So they're giving us the A cubed over B cubed. Okay, I can say that the smaller one is 250 pi, and the larger one is 432 pi. Okay, the first thing I see that I can do is I realize that I can cancel out these pi's. Okay, and so from there, I am left with A cubed over B cubed is equal to 250 over 432. Okay, so from there, if you think about it, you can technically take the cubed root of each side. Remember, you can do anything you want to an equation as long as you do the same thing to both sides. So the cube root of A cubed over B cubed gives you A over B, which is the scale factor. If I take the cube root of 250 and 432, technically, you can think of it like this. It means the same thing to write it like that. And here, we're used to using square roots, and now we've got a cube root, so it's a little bit different. So in this particular case, if you think of it as what's the biggest number that goes evenly into 250 and to 432 is I realize that 125 times 2 gives me 250, and 125 is the cube root. The cube root of 125 is 5, because 5 times 5 times 5 is 125. Okay, so that reduces down to 5 cube root of 2. All right, if I do the same thing to 432, I realize that 216 times 2 means the same thing as 432, and 6 is the number. 6 times 6 times 6 gives me 216. So I know that this reduces down to 6 cube root of 2. And in this case, I can see the cube root of 2 and the cube root of 2 cancel out. So I am left with 5/6. Okay, so it asked me for the scale factor. And so the scale factor is 6. That is my answer. I did want to show you a shorter way to do this as well. I didn't think of a shorter way until I was already writing the longer way. But another option of how to solve this would be just like up here. Ooh, I lost it again. Just like up here, if I get A over B, if I keep it as this big cube root here, I can just reduce down this fraction first within the cube root, the 250 and the 432. If I can just think of a number that divides evenly into both of those, which is 2, then I can reduce this down to 125 and 216. And from there, if I go ahead and take the cube root of 125, I get 5. If that's not one you know, you can do that on your calculator, and please ask if you're not sure. But if you look on your calculator, let's see, above the caret button, you'll see it says X with a square root. So you just have to tell it what X is. So like on my calculator, which is the type calculator a lot of you have, if I want to take the cube root of 125, I'm going to type a 3 because I've got to tell it what goes in for X's place on the cube root. So I'm punching in 3, and then the second button in the top left, and then this caret button that looks like this. And then I'm going to type in the 125 and then hit equals, and it gives me 5. I can also take the cube root of 216, so same thing, the 3, and then the second button in the top left, and then the caret button that looks like this, and then 216, and then equals, and that gives me 6. So that's just a different way. What I did in purple there is just a different way to solve that. Okay, we'll do the shorter way on number 4. On number 4, it's telling me the surface area. So kind of pay attention. Here's volume, and now we're talking about surface area. So surface area is a squared over b squared. If I know the ratio is 144 over 324. And if I want to take the square root of both of these, a square root technically has a little 2 here, but it's not necessary to write the little 2. If you just see the radical, you automatically assume it's a square root. So not necessary to write the 2. But if it's any other root to the third or fourth root or a cube root, then you would write the number. So the square root of a squared over b squared is a over b. And then if I want to go ahead and reduce this down first, then if there's a number that goes evenly into 144 and 324, you can go ahead and take care of that. If you want to go ahead and take the square root of both of those first, and I can tell 144 is a perfect square, so I can take the square root of it and get 12. If you type in 324, It also is a perfect square, which is 18, and then you can reduce those down. Or you might think to go ahead and reduce these down first, which is what I did. I went ahead and said, okay, well, I know 9 goes evenly into both of these. The way I know 9 does, if I add up 1 plus 4 plus 4, I get 9. So since the sum of those digits is divisible by 9, I know the whole number is divisible by 9. If I add up 3 plus 2 plus 4, I get 9. So again, since those 3 digits have a sum of 9, I know the whole number is divisible by 9. So if I go ahead and do that, it reduces down to 16 over 36. So now if I take the square root of both of those numbers, then I get 4 over 6. And then I realize that 2 goes evenly into both of those. So I end up with 2/3. So there we go on number 4. All right, moving right along. On number 5, they're telling me the volumes. And again, same idea here. If I go ahead and say, all right, I know that a to the third power over b to the third power is 729 over 331. Then again, if I take the cube root of each side, then I realize here the cube root of a to the third over b to the third is just a over b. So that gets me down to the scale factor. If I go ahead and take the cube root of 729, I actually get 9. If I take the cube root of 1,331, I get 11. So that gives me the ratio of the sides or the scale factor. Okay, I didn't have to reduce that down first. There wasn't a number that goes evenly into 729 and 1,331. All right, so then on 6 and 7, it says the volume of two similar figures are given. The surface area of the smaller figure is given. Find the surface area of the larger figure. So just be careful, because if these are both cubed and this one's squared, I cannot just set up a direct proportion to figure out the missing surface area. Okay, so I've got to get it into the scale factor first before I can set up a proportion and solve there. So first of all, if I just deal with the volumes at first, I know that a cubed over b cubed, just like we were just doing, is equal to 8 over 27. So if I go and take, just like we were just doing, take the cube root of both sides, then I end up with a over b is equal to the cube root of 8 is 2, cube root of 27 is 3. So that tells me that my scale factor is 2 to 3 in terms of the ratios of the sides. So if I want to figure out what the ratio of the surface areas is, then I know that that has to do with a squared over b squared, okay, which is the same thing as 2. I'm taking my scale factor here and squaring both of these numbers, which gives me 4 over 9. So if I go to use that 4/9, then I know that the ratio of the surface area, since we're talking about a squared over b squared, ratio of the surface areas is 4 over 9. That's the ratio. Now it tells me the surface area of the smaller figure is given. So that number is going to be my top surface area. And the one that I'm looking for is the surface area of the large one. Okay, so now if I go ahead and cross multiply there, then I've got 4 times the surface area of the large one is equal to 9 times 5, which is 45. If I go ahead and divide by 4 on each side, then I get 45 over 4 is my large surface area. And that's inches squared. If you want to write that as a decimal, you'd have 11.25 inches squared. All right, so that's number 6. Number 7, same idea. You can try this one on your own if you want, and then come back and check it. It's probably a good idea to get some practice on that. All right, so this last one on number 7, same idea. We've got our a cubed over b cubed, and that's equal to 64 over 125. If I go ahead and follow the same pattern as last time, I'm taking the cube root of both sides. And once I do that, I get a over b is equal to 4 over 5. All right, so that gives me the scale factor, my a over b. So my ratio of my surface areas is going to be a squared over b squared, which is 4 squared over 5 squared, which is 16 over 25. So if I take those numbers, 16 and 25, and I say, okay, well, 16 over 25 is my ratio of my surface areas. They're telling me the surface area of the smaller figure is 8. And they want me to find the surface area of the larger one. So to do that, I can cross multiply. I've got 16 times the surface area of the large one is equal to 25 times 8, which is 200. I go and divide by 16 on both sides. Then I get the surface area of the large figure would be 200 over 16. But if I realize that 4 divides evenly into both of those numbers, then I end up with 25 over 2 inches squared. If you want to leave it as a fraction, you're going to leave it as a decimal, it'd be 12.5 inches squared. And either of those would give you the right answer. All right, so that's it for section 11.7. Let me know if you have any questions on that.